And welcome to this Ladyada 4th of July weekend edition.
That's right. Happy birthday, America. It's me, Ladyada, and this is my desk where I fight the good fight.
Yeah.
Champion for America, capitalism, apple
Yeah.
pie,
But by the way,
motherhood's supposed
but
to
by
be.
the way, like jerks on social media, like we're a USA manufacturing company that makes electronics in the USA. So, how you spin that? How is that bad? Good luck with that one.
Do you have any other updates, news this
No,
week?
just good luck with that one.
Just good luck. Okay. Um, Thanks to the
Yeah.
to the peanut gallery. Okay,
Yeah.
so we've got some stuff on my desk. It's actually I got, there's a little bit of a thunderstorm today, so I got a bunch of work done. So let's start with this matrix portal. Talk about that first. So go to the overhead. So one design, which, it's actually like I've been meaning to send out for a bit now, and I finally wrapped up testing this weekend, is this Matrix Portal S3. So the original Matrix Portal board used a SAMD51 with an ESP32 as a coprocessor, because at the time there was no such thing as the ESP32 S3. And if you wanted to drive like these LED matrices, you needed a lot of RAM and some fast chip, and kind of the SAMD51 was the only thing that would do a good job with that. So I think even the RP2040 didn't exist yet. So the original version of this board, this looked the same because it was actually the same package, except it was a classic ESP32 room. And it had a SAMD51, and the SAMD51 talked over SPI to the ESP32 and would use that to do Wi-Fi and even Bluetooth connectivity. And like, there's nothing wrong with using an ESP32 as a coprocessor, but it does add complexity and, of course, slows things down. It would be great to do everything in just one chip. And the ESP32 S2 is also, I made a version with the S2, and that's okay. But the S3 has this really cool peripheral that can do like high speed, like bit banging. It's not PIO, it's like the 8-bit wide I2S peripheral, I think, which is also used for TFT, but it's great for driving these RGB matrices where you need to do a lot of like very fast bit banging. You DMA out the pulse widths. So here we've got ESP32 S3, and this one has 8 megabytes of flash and 2 megabytes of PS RAM. So it's got a little bit more flash because I wanted to have a lot of disk space on this. But the overall outline is actually the same. Like all of these holes and this, stemma port and the stemma QT and the up, down, and reset buttons in the NeoPixel and this button, they're all in the same location as the original Matrix Portal SAMD51. And, we have a couple of SAMD51 Matrix Portal. Like, we have them in stock, but the ETA for getting more SAMD51s is like 2024. And so I'm kind of slowly, like, not immediately, but like kind of edging towards like, hey, let's just discontinue stuff with the SAMD51, because it's just, I don't want to wait another year. I've just had so much difficulty. And the S3 is really price competitive. It's, about the same price, about $3 per, and you get the Wi-Fi, so don't need, like, again, two modules for it. So this and then the Pi portals are also going to be redesigned. So this is just my prototype, and I've got the header over here that plugs in, and then I've got this SMT hex nut that I use as like a terminal block you know, for these like spadey connectors. And then, you know, this is running the let's see, let me bring this, actually I'll hold this up. So this is running the sand demo, so it looks much better on the main cam. And oh, there's also a accelerometer here, so that's how I'm using it to do the motion. And then I added one little thing. It's a light sensor. The original didn't have a light sensor, but it was so inexpensive, and I was like, oh, you know, maybe you want to see the ambient light and use that to turn on off stuff. So another nice thing is you can't break the S3. It's got a ROM bootloader. It's just overall going to be, I think, it's going to be less expensive, and it's going to be like as fast or better. So that's the Matrix S3. And let's go to the computer and I'll show just quickly my Matrix portal. Sorry, 1 second. I want to go to portals. And then yeah, so I did the S2 version, but that didn't end up getting made. So this is the Rev C. Later. Let's see. One moment, let me turn on all the layers. Okay, so you've got, you know, this nice silk screen fill B made for me. One thing I changed, this is the Rev B that I showed on the overhead. One thing I changed is I'm actually going to have 2 SMT connectors. I'm going to have an IDC connector pointing up and then a 2x10 socket header pointing down. And so right now I have the socket header plugged in, and that allows you to just plug directly to the back of the Matrix displays. And it's a standard pinout hub 75 is what it's called. But there are some times where you might want to mount this separately and then have a cable that connects from the driver to the Matrix portal to the LED panel. And so this is an IDC connector, so you can see the outline. So this will allow you to plug the cable in. So it's going to be kind of weird. There's going to be 2 SMT connectors, and it's going to look like they go through, but they actually are like just both sandwiching the PCB, but one plug in and one cable in. So, you know, it's good because one thing that people did say is like, hey, I don't want to have it plug in directly. I want to have it mounted elsewhere so I can press the buttons. You got the level shifters to give you the 3 to 5 volts. This is the S3 module. We use every pin on here, which is nice. I still have a all these pins available, so these GPIO. In addition to the, you know, the reset, bootloader pin, debug output. That's just the UART, hardware UART debug output. And then a bunch of GPIO, including, you know, basically 5 analog inputs and 3-volt ground. Stomach QT if you want to plug in sensors. You know, one project that was very, very popular with the Matrix portal, and I'm going to, you know, make sure that we can recreate it, is the CO2. This project from Carter was very, very popular, which allowed you to make a, you use the LED display to tell you how, what the air quality is like based on the CO2 readings with a common CO2 NDIR sensor, the SCD30. And what was nice is that there was like no soldering required. You plug it right in, and then, like, you know, it would read the sensor data and display it. And particularly having, you know, this very simple to read and understand display was kind of nice. So one thing that we did after I did the Rev B is I gave them to Melissa, who did the Matrix Portal CircuitPython library. And I said, hey, can you go through and just verify every single guide works? You know, even though this is now an ESP chip, not a SAMD51, and she went through and tested every single guide and fixed a couple of like typos and bugs in the meantime, but verified that they all work. So what's nice about Arduino and CircuitPython is it's really easy. Like if your hardware changes underneath, it actually might be okay. The Matrix Portal library actually, you know, it's Python, and it just checks like what board am I running on, and it changes the pins for you, and it like kind of magically works. And then I also added some mounting holes here, so you can see these 4 mounting holes. Again, in case people want to mount this separately than the main board. So this is the first of the SAMD51ification. Love the SAMD51. Bummer. It was like really one of my favorite chips, but it's like broken my heart too many times, and it's just time to let go. If I was a country music singer, I'd probably have like a song about it, but I don't. I can't sing country. Okay, so let's go back to the overhead. And I'll show some other stuff I'm working on. Okay, so that's that one. This one's done. So I ordered PCBs to get this completed into the shop. So see it soon. It'll be cool. And then I also, you guys maybe have seen this a couple desk of Ladyada's ago. This is a Cutie Pie BFF that has a 3-watt I2S amplifier chip. You can kind of barely see it underneath here. This is such a nice overhead. There you go. I2S amplifier here, and then also squeezed in a micro SD card slot, so you can turn this into a little audio player that has digital output. One thing I made a mistake on, you can see, is the LR clock, the word select clock, and the bit clock. For ESP32 chips, they can be any pin. You can use any pins you want. And the RP2040, you can almost use any pins, but the pins have to be consecutive in a certain way, and I had them consecutively the wrong way. Like, I think the LR clock was before the bit clock, either the bit clock before the LR clock or whatever. So not only do they have to be next to each other, but one has to come before. And so I kind of just like cut and quickly soldered. I mean, it's filthy. You can see I can cut the traces and then wired them with the little wire wrap wire, but it works good enough. And then this is the RP2040. So let's see if we can do a quick demo. Let's see. It has a little audio clips on there, and so that's also working. Other than that, I fixed it, and now I just test it. And to do my testing, I've got this bin called Cutie Pie, and it's a bin with all of my Cutie Pies and BFFs and everything. And so I pull them out to quickly test to make sure that it works with all of them. So I've got, this is the S3, and I've got an S2, and I've got the SAMD21. The audio BFF won't work with the SAMD21 because the I2S pins actually intersect with the SPI pins. But honestly, I would say, hey, instead of using the original SAMD21, which is now a little bit long in the tooth, update to the RP2040. Here's another ESP classic. This one also, I'm sure works. I'll test this as well. One thing I did want to mention, it's not out yet, but coming soon, is a new Cutie Pie S3. This time it's going to come with PSRAM. I forgot that the chip, originally when I made the Cutie Pie S3, it came with 8 megabytes of flash because that was the only version available. Then they came out with a version of the chip that has PSRAM built in. So I made a PSRAM Cutie Pie, which will be really good for CircuitPython. All right, so that also got wrapped up today, which is wonderful. So put that aside. And then so the next thing I'm going to work on, which will lead into the great search, is this is an RP2040 Metro, which you can see because it's right in here. And I think I showed off the schematic, but finally I have the boards completed. So it's got your RP2040, boot button, reset button, STEMMA QT port, USB Type-C, micro SD in this spot here that is normally, I'd put like a Wi-Fi something or other or some other accessory, but micro SD fits very nicely and it's always very handy. I did wire up the micro SD for SDIO, not just SPI. Like there were enough pins that I was able to pick some pins that the SPI ports connected for like standard SPI SD card usage, but also SDIO in I think the right order. So you should be able to use one or the other. SDIO is not super well supported, but there is an example for it in the Pico SDK. So that'll be kind of interesting if you want maybe super high speed micro SD card reading. and SWD port. And then I also put in the standard, Pico debug port, which is SWD, but over this like 3-pin connector. On-off switch for the DC jack, and of course, 5-volt, 3-volt regulator, and SPI port. And this is kind of funky. I think I mentioned this before. Normally, the pins on an Arduino or Metro, this compatible layout is D0, D1, D2, and you see like from D2 it goes up to D13 in order, and that's like super cool and everything. But also D0 and D1 are used for the hardware UART. But the way the RP2040 works is you can't pick any pins for hardware UART. They have to be a certain subset of pins. There's a lot of them, but you can't just pick any like pins. So 0 and 1 can be UART, but it's the opposite way of how most Arduino or Metro boards are wired. I think like normally TX is D0 and RX is D1. And so I have a switch here, and you can flip these two pins around. So either you get numerical order 0, 1, 2, 3, or you get like a logical order where you get the UART in the order that you expect with RX and TX. But also maybe handy if you wire something and you're like, oh no, I wired the UART wrong, just to like flip the switch. I love it. I think everything with UART should come with a little DP/DT switch, just like swap it around. So I actually sent one of these out to a couple of remote engineer folks, creative engineers, and they actually tested it so far. So I'm going to do a last pass, just check all the GPIO, check that the USB is wired correctly, the micro SD, do some, make sure the DC jack is going to work at various voltages, and all the SWD ports and everything. Oh, there's also a NeoPixel here that I didn't solder in. But, and then of course we'll do a nice silk screen for it. So now we can go to the great search.
Where in the world is that part I need? The great search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit every single week. Ladyada user power of engineering help you. Yes, you find things on digikey.com. Ladyada, what is the Great Search of the week this week?
I'm glad you asked. This week's great search is we're going to look for some 2.1 millimeter DC jacks. Let's go to the overhead and I'll show my design and the part I picked. I'm focusing. Stay on target. So for this Metro RP2040 prototype that I'm working on, one thing I really like about this shape, this is kind of the classic Arduino shape, which I call Metro because I don't want to use the word Arduino, it means something. But for those boards, which I really like, they're kind of nice and big. And one of the side effects of having plenty of space is that you can have a lot of accessories. So not only do you use USB Type-C or Micro B for power and data, and there's a reset switch into the micro SD card slot, but you could also have a DC jack. And, even though a lot of things plug into USB these days, like almost every device I buy these days has a USB port for charging, there are times when having a DC jack is really handy. These DC jacks can provide up to 12, 24 volts. They can do 5 amps. Yeah, USB-C can do that as well, but it's often easier to get a DC power supply that you have handy, and then that voltage ends up out here on the VIN pin. And so if you want to use it for powering motors or steppers or LED strips or solenoids, or actually a lot of industrial equipment uses 12 volts. So, if you need 12 volt DC, yes, you could make this USB-C do power delivery and get 12 volts, but it's easier to just have a dedicated non-power delivery port here that are going to give you 9 or 12 volts DC. So let's go to the computer. I'll show some other stuff that at least at Adafruit we stock that uses the same size. So this is an example of the DC jack with a switch built in. But you see it uses this kind of standard barrel connector used in, there's a lot of different sizes for barrel connectors. There's 5.5 millimeter outer, 2.5 inner, 4 outer, 1.3 inner, but the most common that you see these days is 5.5 outer diameter. That's the diameter of this jack is 5.5 millimeter. And the inner diameter, the little nubbin that sticks out that's 2.1 millimeter diameter. So see, we have a lot of adapters and plugs and cables. And if you look at, we have a 12 volts, 12 volt, 1 amp power supply. This also has the same 5.5/2.1. So, a very standard connector. And, yes, eventually in some magical future, we'll all be using USB power delivery, but we got at least another decade of this stuff. So if we want to use these sort of power adapters, we'll need to get a DC jack. And there's a couple things I've learned about using these DC jacks. So I'll show you what I've learned, because this is, before USB, this is kind of the standard. If you look on electronics from like, the 70s and 80s, basically once they started not using mains power directly with devices, they went straight to wall warts or power adapters. This is the standard connector. So let's look for DC jacks. And there's a couple things. So there's cables. So if you want cable assemblies, this is one category. But what we want, and this, you can actually see this is a inline adapter, but we want something that goes into a PCB. So let's go. Oh, and also if you want, of course, power adapters that this goes with, DigiKey stocks, every voltage, current, whoa, that's weird. It goes the opposite direction. Usually, because I typed in jack. If I typed in plug, it would have plug versions. So I was like, why is it the opposite polarity? This is, here you go, like this one. So you see, this is this very standard wall adapter. You plug it in and they come, there's versions also that are, that come with, a European, Australian, US, Japan, etc. Different voltages. This one's 12 volts, 12 watts, but they go up to 24 volts easily. So let's look at some of the voltage outputs. There's some adjustable voltages, but it's not too, you can get up to, I think, 24 volts DC. Yeah, so it's like you need a high voltage. You're not going to get 24 volts out of USB power delivery. So also it's maybe a little bit less expensive because you're not dealing with the overhead of USB Type-C, which needs its own like big power plug. So let's go back and look at again DC jacks. So under barrel power connectors, barrel type, because it's round and thin and circular and has a hole in the middle, so it's called a barrel type. So let's just look at all the power connectors and take a look. So there are tons of these. So this one you can see here, it's 3.4 by 1.3 millimeter. This one is 5.5 by 1 millimeter. So this is a SMT version. This is a 2.35 by 0.7, so much smaller. I'm not a huge fan of these, but I will say that this size is very popular on USB hubs. If you want to have optional external 5-volt power, because these are a little chunky. These are available. You can see this is a through-hole style, another through-hole, kind of narrow SMT, a little lower. This one is SMT, but it's pointing straight up, which is kind of cool. This one is like to the side. So, different orientations and stuff. So first up, let's just go and look only for the active and in stock. I picked in stock items just to pare down to the ones that we want. We want a jack, not a plug. I will say that trying to use female or male gets very confusing because it's like there's, which way is the gender? It's unclear. So I would not use the word male, female when trying to differentiate between what plugs in and what gets plugged into. Instead, use plug and jack. Jack is the thing that you plug into, and plug is the thing that, is plugged. So especially when you're dealing with connectors that have like multiple like sinusoidal connections and inputs and outputs. So we want a jack because we want something that it gets plugged into. A plug is what comes out of the wall. And now this is kind of like the thing that engineers have to deal with. There's what it's called, and then there's what it is. So we call it 5.5 millimeter outer diameter, 2.1 millimeter inner, but that's not actually the measurements. The measurements can actually be 2 to 2.05. So let's just look, if we just filter on 550 millimeter outer diameter, you'll see that first off, there's this like funky 1.6 millimeter. These are odd. And then there's also the 2.5 and 2.55s. So there is a variant of this jack that looks like identical, except the inner pin is a little bit wider. And that means that it can carry a little bit more current. So technically, you're not really supposed to take more than, I think, 60 watts, maybe 5 amps over a 5.5 millimeter, 2.1 millimeter jack and plug. So if you want more wattage, you have like a monitor, a computer, like something that needs 100 watts, you're supposed to use 5.5/2.5 millimeter. Whether people do or not, I mean, sometimes they do, sometimes they don't, sometimes they go to another connector. But you'll definitely want to make sure you can, if you plug a 2.5 inner diameter plug into a 2.1 millimeter jack, you won't get power coming through. It'll look like it's plugged, but like the thing won't turn on because the pin isn't touching the cup. And if you're using a 2.1 millimeter jack and a 2.5 millimeter jack and a 2.1 millimeter plug, it won't plug in. Like you'll try and it will like it's like no matter how much you force it, it's not going to go in because it's 0.5 millimeter too big. There are once in a while jacks that can do either by using like a little bit of a spring, and it's 2.1 millimeter, but it pushes the pin up. So like even if you have 2.5 millimeter plug, it'll still fit. Just pick one or the other. I don't like to play these games where it's like you can kind of make it work. So in which case we're going to go for 2.0, 2.05, and 2.1. So there's a little bit of variation. It's basically all the same. And we're going to skip these. Wow, there's even a 3 millimeter. So like, again, totally non-standard, but it looks, to the human eye, it looks the same, but it won't plug in. Okay, next up. So there's a couple different versions. There's the SMT and through hole. I have used SMT. The SMT is actually fairly strong. I'm not using it on my design. They tend to be a little bit more expensive usually, but you would also definitely need to have really big pads. I don't know. Let me see. I think one of our solar chargers uses SMT. Yes, this is the SMT. I've used it. It works. It's not as mechanically strong, of course, and especially because again, people might try to plug in the wrong side. They can actually put quite a bit of force on that connector. If you do go with SMT, make sure you get the kind with these nubs that help, like they stick through the circuit board and they give you mechanical strength. Because this connector is not only electrical, but it's mechanical. And it's a very, very common thing that the DC jack is what cracks off and the thing stops working because it's easy to torque it, or, you've got the plug plugged in, and the plug, it's kind of large and chunky, and it's a great lever, and your device falls off, the cable gets strung up, it pulls and it yanks it out. So for this design, it's a little breakout board. It's an older design. It's okay. You can do it, but if you're going into production, you're manufacturing something that's going to be used by people in their homes often, or by folks who might be a little bit rough. I would not go with the surface mount. I would go with the through hole. So let's select, not panel mount, let's do through hole. And then there's through hole and there's through hole right angle. Because there's the ones that stick up. I've personally never used the ones that stick up, but like they're very cool and I'm sure they work just fine. And if your design happens to need the power going up, more power to you. Do note you can, for through hole, there's also, so these are the jelly bean. They're almost all the same. They have these 3 pins. So inside is a switch. And the switch, so there's 3 pins, but you're like, oh, there's only 2 pins on the contact. There's a switch here that is normally closed. And when you plug it in, the 3rd pin disconnects from the 2nd pin. And you can do that to have like an internal, like first we can detect whether, something got plugged in, or you can use it to switch out to a battery power. However, there's one thing you got to watch out for, which is that the thing that's switched is the ground, not the power, which means that there might be another path to ground some way or somehow. And so you'll notice that pedals, guitar pedals used by musicians, have center negative so that this is switching the positive pin. However, nobody else in the world does that. Everybody else in the known universe uses center positive, which is what you're almost always going to encounter. So stick to center positive. And then if you want, you can use the switch, but just remember it switches the ground out, not the positive pin, which is, you might have to think about your grounds and your earth grounds, make sure that there isn't another path through, or you might be surprised when your battery shorts to your power adapter. Okay. One more thing, there's these thin pin style. Again, I'm not a huge fan of it. I feel like if you're going to go for it, go for the large chunky pins, because you want a mechanical connection, not just electrical connection. However, side note, these do plug into breadboards. They plug in quite nicely. So if you're having to solder this into a perf board or a breadboard or something else that's 0.1 inch spacing, this actually ends up working out quite nicely, and the pins go right through the holes. We don't want that though. We want something with, chunky pins. Another thing to watch out for is they're not all rated for the same amount of current and voltage. Some are rated for 2.5 amps, some for 5, some for 24 volts, some for 48 volts, some just for 12. So they're all kind of the same build, but the rating is the rating. So you should probably obey the rating. Wow, this one goes up to 10 amps. This is kind of a nice, ooh, look at that one. It's got like all those contacts. This is very nice, but it's a little bit more expensive. It's almost $4. So let's sort by price, and then we'll just see what's up. I don't want the vertical, so let me change the mounting type, and I'm going to get rid of, I want right angle. Yes, I'm going to get rid of through hole so that I only do the right angle. This one's pretty good. Let's see, but maybe I want the 5 amp version. So I think this one's kind of nice. And I like it's got the big chunky pins. Oh wait, this one doesn't have the switch. Never mind. Hold on. That changed my mind. I'm gonna go for the version with the switch. Single switch, normally closed. Because I actually like, even though I don't use the switch, I like the mechanical connection. Okay, back here. Let's see, this one, 5 amps. This one's good. Okay, this one, I like this one. It's got the pins, nice thick pins, standard layout. It's got the kinked pin, so when you solder it in, it stays in place. Don't forget you'll need plated slots on your PCB to make sure that these fit in nicely. Although you can also use big round holes, it just makes it a little tougher to fill it with solder. So I use plated slots. Just check out your CAD program on how to create plated slots. All right, so if you need kind of your generic 2.1 millimeter, 5.5 millimeter DC jack that can do up to 5 amps, up to 20 volts. This one's pretty good. I'm going with this one, the GCT DC J200. It's my pick. The great search.
That's a great search.
Where in the world is that part I need? The great search with DigiKey.
Okie dokie. Thanks for joining us this sort of holiday weekend. Thank you so much, everybody. We'll be doing our shows and more all throughout the week. Lots of surprises. And only in America could something like Adafruit happen and someone like Lamore do it. So, we've got our problems, but it's better than the alternatives. So, yeah. And I mean that as our country, not as us. Okay.
All right.
This is the least worst thing going on. It's not so bad.
Could be worse.
It's not so
Okay.
bad. All right, everybody. Thanks so much.
Thanks,
We'll see you
everybody.
later. That's your desk of Ladyada.
Don't blow your fingers off this week.